This is notes 1-6, solving compound and absolute value inequalities. So we're going to go over compound inequalities first, and then you have an AND statement. So this is an example of an AND statement, and you would say like this: -3 is less than or equal to 2x plus 5 and is also less than or equal to 19. Okay, so that's how you would write an AND statement. Normally, pretty much all the time when you have an AND statement, the shading of the graph is like this. And actually you can tell that, you can come up with that logically if you just look at this instead of looking at this whole thing here. Or if you just look at those, it says x is greater than -4. Now greater than -4 would be, it would shade everything to the right. Now this one also, but and x is also less than or equal to 7. So less than 7 would be everything to the left. Where the two shades overlap, that's represented by this shaded region. Okay? So again, on an AND statement, you're going to have overlapping shades which then will form this shaded region right there. An OR statement, normally they would, that's an obvious one because they normally write an OR. Okay, an OR statement, normally, pretty much all the time, the shading is going to be on the outsides. And if you look at this, you can actually just make sense of it just by looking at it. Y is greater than or equal to 3. Greater than or equal to 3 is including that, and then to the right. Remember, greater than is to the right. Now, y is less than or equal to -4 would be everything to the left, including 4. 4 and everything to the left. Okay, so let's take a look at a few examples of how to solve this. Now on this one, if you look at the example 1 on here, they actually broke it apart, and you can if you want to, alright, but normally what I like to do with these is I like to solve them at the same time. So what you can do is you can start off by subtracting 2 here. Notice that I'm starting from the middle, alright? I'm going to subtract 2, very similar to solving an equation, a linear equation, and that's going to cancel that, and that would give me less than or equal to 12. But also, I'm also going to subtract 2 from the left side, alright, and that would be -12 is less than 3x. Now again, remember that if you don't want to do it like this, if that was confusing, this is basically what I'm doing, but all in one step instead of me having to rewrite 2 equations, right? So feel free to do it like example 1, or you can do it like me. It doesn't matter. Now the next step is I'm going to divide by 3. Now if I divide by 3 here, I'm going to divide by 3 over here and over here also. So this is going to give me a -4 is less than x, which is less than or equal to 4. Now remember, if I were to divide by a negative, if this would happen to be a negative, now I would switch the signs, but that didn't happen, so I'm going to leave it alone. Also notice that on an AND statement, normally the number right here is smaller than the number out here. Okay? Now if you look at it one at a time, if you have any questions, x, notice how I'm reading from the middle out. X is greater than -4. So greater than -4 will be everything to the right, and x is less than or equal to +4. Now since it's equal to, that's going to include that number in the solution, and less than 4 would be everything to the left. So where the two shades would overlap, that would create this other set of solutions. But in general, if you have an AND statement, you're going to have the shade is always going to be in the middle. Alright, let's look at number 2. This is an OR statement. Alright, so one more time on this one. On this one you do have to do 2 equations. It's just the way it is. So we have, let's see, we're going to subtract 8 from each side on here. So we have 3a is less than 15. And we're going to divide both sides by 3. So a is less than 5. On the other side, I'm going to add a 6. So I'm going to draw a line here so it doesn't get all smashed together. So I'm going to add a 6. So I have 1/4 a is greater than 13. And remember, how do I get rid of that 1/4? You can look at it 2 ways. You can either multiply both sides times 4, or we can multiply times their reciprocal. Well, 4 over 1, well, that's just 4. So that's going to cancel this. So I have A is greater than 52. All right. Now to graph this, since this is an or statement, so A is less than 5 or A is greater than 52. So less than 5 would be around here. And notice that is not equal to, so I'm going to leave this dot open because 5 is not included in the answer, and then A is greater than 52. So let's say that 52 is around here. And it's not equal to either, but it is greater. So I'm going to shade everything to the right. So remember, don't sweat it too much. I don't know exactly where 52 is on here, but that's approximately where I think it is. All right, so, all right. I'll do perhaps one more like this one. This one's the same thing, and I'll show you what the answer is at least. But on this one, right, try to do this one on your own. So pause it right now and try to see if you can do that one. Now, assuming that you have tried that one, all right, let's quickly do it. Now, again, remember, you can do this like example 1, where you write both equations like that, or you can do it all at the same time like I am. So I'm going to start off by adding 10, and I'm going to add 10 to both sides. By both sides, I mean that one and that one. So that's going to give me 28 is less than 4x, which is less than 60. All right, now I'm going to divide by 4. So this is a 7 is less than x, and x is less than 15. So you can notice how that number is smaller, this number is smaller than this one, and that's how you can tell if you did it right if you're working with an AND statement. So if this is a 7, not including 7, this is not including 15 because they're not equal. Alright, so none of these have the little line that represents equal to. So therefore, the solutions are going to be in the middle. Alright, but remember the logic. That means that x is greater than 7, which is to the right, and x is less than 15, which is to the left. The overlapping is where the solutions are located. Alright, on number 4, feel free to do it yourself. I'm just going to give you the answer. I got k is less than -3, or k is greater than 5 over 2. Okay? And remember that 5 over 2 is it's 2.5, so you can kind of graph that on here. Alright, so let's go to the back. So now let's work on absolute value inequalities. Alright, so on this one, notice that we have an inequality that involves an absolute value, and when that happens, you're actually going to have two cases, almost exactly like we did in the previous notes. Alright, what you're going to do here is you have a case in which this is the answer. Excuse me, that's one of the questions. And the other one you have, this is one of the cases, and this is the other case. Alright, so you have two cases, one that looks like this, and one that looks like this. So notice that what happened, in case you can't tell, is that this one is basically this one. It's the same. But in this one, I switch the inequality, and then I make it negative, or make it the opposite sign. So notice that this is originally a 4, but now it's a -4. Okay, and then on this one right here, you just have to be real careful, because on this one it's going to be kind of hard to tell if it's a and or an or statement. So this one you really do have to work through it to figure that out. Okay, and on this one I'm not going to do it at the same time. So let's take a look at example exercise number 1. So in exercise number 1, I have two cases. One case is going to be 3x plus 4 is less than 8. And the other case is going to be 3x plus 4 is greater than -8. All right, notice I switched the inequality, and then I also made that negative. All right, so now we're going to solve each one separately. So we're going to subtract 4 from each side. So we have 3x is less than 4. Then we're going to divide by 3. So we got x is, wait a minute. Yeah, 4/3. Okay. And I'm going to grab a calculator just to make sure. I'm going to have to write that as a decimal point. I'm assuming it's going to be like 1.333, but let's just make sure. It is, so you can use your 4-function calculator if you have to. So 4 over 3 is 1.33, right? So this is 1.333, right? 4 decimal points, and on this one right here, 3 decimal points. We're gonna subtract 4 from each side. So this is 3x is greater than negative 12, and then when I divide by 3. I get x is greater than negative 4. Okay. Okay, so after that I'm going to graph it. Now, there's another way to do this, and I'll show you here that in a minute. But if you have this right here, let's just look at it. I have x is less than 1.33. Alright, so let's say the 1.33 was right there. Now, less than means that I would shade everything to the left. Okay. Now x is greater than negative 4, which is this one, means that I would shade everything that's to the right of negative 4. Alright, so if I were to shade everything to the right of negative 4, where the two, in this case I wrote in highlighter, where the two colors combine is right here. So this is an and statement. It turns out that this is an and statement, and I can tell that because the shading is in between. Okay? Now, on number 2, we must isolate, if it's not already, we must isolate the absolute value. Okay, so if it's isolating the absolute value, then I must subtract 1 before I do anything else, and I get the absolute value of 4k is greater than 26. And this one's going to be a pretty quick one. So I have two cases. I have 4k is greater than 26, and the other case is 4k is less than negative 26. Alright, so now if I divide this by 4, I would get k is greater than 6.5, and again, you can use your 4-function calculator for that. If I divide this, well, this is going to be the same. And again, notice that when I change this inequality, I switched the inequality from greater than to less than, and then I made that a negative number. I made this a negative number, excuse me. Alright, so again, this is going to be k is less than negative 6.5. Alright, so 6.5 is right, let's just say it's around right there. Greater than means I would shade everything to the right. Okay, so everything to the right. And then negative 6.5 will be, I don't know, somewhere around there. And I would shade everything to the left because k is less than 6.5. Okay? So this happens to be an OR statement. Alright, so this is an OR statement. So finally, the other way to tell, alright, if you're like, well, I think honestly for me this is more logical. So I actually like to do it like this. So on this one, it's an AND statement. Notice that if you want to write it as an AND statement, if it was a multiple choice, for example, I will write the smaller number, and notice it says x is greater. Alright, this has to be pointing the same way. It's opening towards x. And this is 1.33. Alright, so this is how you would write the AND statement, if you want to write it like that. Right, an OR statement, since I know it's an OR statement, I really don't care to put it in order, so I'm just going to put an OR here. Okay, so that one's a little bit easier. Now, in general, if you have an absolute value, if it's by itself, and you already have a less than, alright, notice that the absolute value is less than, then it's going to be an OR statement. Alright, without me actually doing any of the work, I know this is, it's going to be an AND statement. So again, this is going to be an end statement only because I know that the absolute value is less than. So anytime it's less than, this is going to be an end statement. Right? And when you have an absolute value is greater than or equal to, in this case, this is going to be an or statement. So without the logic, you can kind of just do that. However, I would still recommend that you do it like this to just so that it'll make sense in your head. All right? So I'm only going to do number 3, and I'll show you the answer for number 4, and we'll just call it a day for today for the notes. All right, so we have one case where we have this. Okay? And then we have another case where we have this. Notice that I'm switching the inequality. And then we have a negative 5. All right. So on this one, I'm going to add the 3. Add the 3, I have c over 2 is greater than or equal to 8. You can, on this one right here, to get rid of the c, I am going to multiply both sides. Excuse me, to get rid of the 2, not the c, I am going to multiply both sides times 2. Right? I always want to do the opposite to get rid of something that's attached to the variable. So since this is division, I'm going to multiply. So this would be c is less than or equal to 16. And then the other side would do the same thing. We'll do the same thing. So I have c over 2 is greater than negative 2. And I would do the same kind of step. I'm going to multiply by 2. So this would be c is greater than or equal to negative 4. Okay. Now negative 4 is right here. Notice that it's including because it's equal to. And this is 16 right here. And I know this is an end statement, but if you didn't know, you can do the type of shading that I did up here. All right. If you really wanted to, you could also write it like this and solve it all at the same time. I have this. All right, on the other side, I would have this. And then you could solve it at the same time like I did on the previous page. All right, you can do it all. However, it's really up to you. Just make sure that it makes sense to you so you cannot get confused on a quiz or a test. All right, so finally on number 4, I'm just going to show you the answers. I remember what I told you, this is going to be an or statement. Well, why don't you work it out and figure that out yourself. And this is what I got. This shouldn't take you any time, really. Okay? And then I'll let you shade it yourself. Now, all right, before we go on, though, I want to write the answer, right? So assuming that you did this, I want to write the answer for this one as an and statement. So remember, the answer was, let's see, this was 16 over here. And don't forget, if you have like, man, I don't know how to write that, I don't know which one to write first, the smaller, if it's an and statement, the smaller number is going to be on the left, and the larger number is going to be to the right. All right, so this would be the answer if you want to write it as an and statement. Okay, well, I hope this made sense. Make sure you ask questions tomorrow.